But before we start, it's a personal event we need to celebrate. It's the birthday of Gauthier, here present. So the party is all on him tonight for the people who are staying. Unfortunately, I'm not. And having said that, don't forget to join the Biomérieux European Directory Conference on LinkedIn. There is a group that you can scan. There is also a webpage from Biomérieux. All the brochures that you can see here can be downloadable. So if you want to be very sustainable, or if you are not a registered luggage to go back home, the PDF file, we do it all. And as for the next speakers, I'm going to introduce them one by one during their respective presentation. Just for myself, it's a bit strange, but being French, it's okay to self-promotion is something we have in our genes. So I will deal with this. So I'm a food safety microbiologist for more than 20 years in the industry. I'm working as an independent consultant, family choice. My wife moved in the countryside to move for a company, so I followed her, and this is what I've been. We've been living in the countryside for the past 5 years, so we anticipated the new society before the COVID, so we were prepared for all the lockdowns. But it's good to be back and meet everyone now. And since 2010, I'm delegate at the IDF, the International Dairy Federation, and I'm going to speak about one of these subjects right now. And being French is not enough. I'm also dealing with Dipartimento di Scienze e Tecnologie Alimentari per una filiera agroalimentare sostenibile. That's Italian. In Italy, but I'm still French. And I'm going to talk today about the microbiological criterion, this great stranger, because we take a lot of decisions, sometimes business-based decisions on the microcriterion. And often, as microbiologists, we are dealing with people who don't understand, in fact, what's the meaning of the microbiological criterion and how you go beyond the results. And that you need to have some reflection upon what's going on. So you see the wonderful Università Cattolica del Sacro Cuore. So the initial title was The Fisherman, the Boat, the Fishing Rod, and the Lake. But I've been told that this was not very understandable by everyone, so we have to take a more serious one, the analysts, the laboratory, the ethical method, and the sampling site. And that's what we're going to discuss in the next 45 minutes. One of the issues we face a lot when you speak about microbiological criterion is that people just block their brain, have the statistics behind the representatives, the sampling, but they don't really understand what it means in terms of objectives. And something I personally have to do often when I go to factories is use common terms that speaks to everyone, and therefore, switching to what I mentioned earlier, the fisherman, the boat, the fishing rod, and the lake. If you switch to real life, most of the scientific-based situation, people understand it more specifically. Like if you go to a factory and you need to explain them that they should upgrade, and they say, I don't understand, this factory has been going for 20 years, why should we upgrade the factory? And you ask them, how old is your car? Is it 20 years old? No. So you upgrade your car, maybe you should upgrade the factory as well. Then they understand that indeed, if the factory was built with a standard from 20 years ago, it's not up to today's standard. But if out of the blue you go directly to upgrading the factory, they just don't get it. That's impressive. I don't know why. The microbiological criterion, the concept has evolved a lot. I know that people don't like the Codex Alimentarius text because they seem to be boring, but in fact, they are very meaningful and very helpful if you take the time to read them. The first document in place for the microcriteria was in 1981, and that was really border control. You have no history of the product, you test, you accept, you don't accept the food product without any knowledge how it was produced, where it was produced, what was the risk assessment in place. Even in 1981, risk assessment was not something that was conducted as good as it is today. And just these guidelines took almost 20 years to be established. From the initial Codex work until the publication, that's around 20 years. The next one was only done in 15 years, which for Codex is quite normal, and that was more HACCP-based. That was following the implementation of the HACCP by the ICMSF, and we had an upgrade of these guidelines 1997. And that's more process calibration and to have a look at the validation of the control measures, because per se your process is in place because you have a set of control measures around the process, and then you implement a monitoring on the control methods that do make sense with specific validation procedures for the critical one. In 2013, in fact, we started in 2010. It was quite fast. The revision only took 3 years. We worked more on the SPS LOP, Acceptable Level of Protection, the 1995 Sanitary Phytosanitary Agreement, and try to be more risk-based. So really put some science and using the risk analysis framework. Not going to invest too much time into the risk analysis framework. That will be the subject of the next presentation. But it's always important to take the time to reflect before you act. And we worked on the definition. Codex documents are most of the time based on a set of definition, which takes quite a lot of time to establish. And this one really specified that the criterion is a risk management metric. So when you look to risk management metric in the risk management document from the GEMRA, so publication both from the FAO, WHO, they mentioned the performance objectives, the food safety objective, whatsoever, which are the metric based on the SPS agreement. The microbiological criterion is the old-fashioned metric, which is more adapted to this one, but working on the acceptability of food. And per se, that was also implemented in the EU regulation. So we have the chance that in Europe we have two sets of criterion: the food safety one and the process hygiene criterion. Food safety is very clear. If you don't pass, if you have an issue, you need to discard the batch. Process hygiene criterion is more sensitive because once you have an issue with the acceptability of your batch, what should you do? You're not forced to recall, but then that's the decision that you need to have. Is it safe for the brand? Should I recall? Should I make a silent recall? Should I inform the authority? Does this hygiene failure means I might have a safety issues? So this is where it's also important to have in mind. If you test, you have to be ready for the result as well. And all this micro-criterion, also we define which were the components. And when you speak of micro-criterion, most of the time, people, they are focused on the sampling plan with the N and the C, but that's only a part of it. What's an important thing, if you work with a micro-criterion, you start with a purpose. They always start with a why. If you test, there is a reason why. So you must know why you're testing. And it's also where it does apply. It's on the food, on the process, on the food safety control system. It's more than just finished product testing. And so that's also what mentioned here, the specified point in the food chain where the microbial criteria applies, not only from the primary production to the consumer, but also within the process of your factory, for example. You need to have a look at the microorganism and the reason for its selection. There must be a rationale. It's not because the regulations say so that you should have a look. One very important point is that most of the time, food business operators, they refer to the 2073/2005 regulation, microculture for foodstuff. They just forgot there is one regulation above this one, the 178/2002, the General Food Law, Article 14. I revised before, I don't know them by heart. We mentioned that it's your responsibility as a food business operator to ensure the safety of your food, which means that the 2073 regulation for the criteria should be seen as a guideline. That's the non-negotiable. You need to comply. Does not mean it makes it all. And that will be the topic of the presentation of Marion for plant-based. Plant-based per se are not in all the list of the food criteria you find in this regulation. That does not mean there is anything to do. It means that for this you need to make the global assessment. We have the same discussion going on with insect food. We have the same discussion going on, presently pretty hot topic, under the codex with the new food products like precise fermentation and cell-based technologies. They are not in the EU 2073 regulations, but they are still under the 178 regulation. It's pretty boring, I know, but the point is to have in mind it's your responsibility to ensure safe food, which means that you need to take time to reflect. Which means that the micro-criteria per se, it's not only in the finished product testing at the consumption level, it can be at different points, which is a good news for the food business operator. If you think you're testing enough, maybe in fact you're not testing enough. And the more you test, the more you might need to test as well, but switch a little bit away from the finished product and go more investigating around the food chain where it might make sense. Having in mind So I'm sorry for the quality, but that's a very old paper. That's testing does not make it all. Following the recent outbreaks we had in Europe on milk powders, people often refer to a publication from Abraken from 1986. Most of the people didn't read this publication first because it's not in databases. It cannot be brought online that easily, so you need to invest, and the best is to have some Dutch colleagues, Dutch friends that can, for you, find the publication and make a PDF. So I want to thank Wageningen for providing me this one. And the introduction, it's mentioning out of the blue, the lack of reliability of finished product testing is known by microbiologists. And in the list of references from 1 to 6, one traces back to 1931. So for the microbiologists, for more than a century, we know that testing on a finished product is satisfying for the regulation, and that's almost all it is. The rest is you need to make the hard work on the shop floor. And that was also, since today we are working on the European Dairy Quality Conference. That was about this publication from CSIRO, from the Austrian in the 60s, 70s, about testing. They mentioned the same well. You cannot do it all. That was as well the conclusion in 2005 in France, following the first outbreaks of Salmonella agona in Crans-Mayenne. Routine microbial controls are insufficient to detect a low-grade contamination, which is a paradox. The more you work, the more you do a good job, the more you need to test, because you're getting so good that the testing cannot show anymore, and there is a default. And depending on the type of population you're working with, in the present case that was neonates and infants, they are very insensitive, which means clearly you're in the Apollo 13 mode, failure is not an option. But how do you detect failure, knowing that by finished product testing, you won't see it? And that was the discussion from the 2017 outbreaks, where the company implicated was not understanding why they made more than 17,000 analyses and they didn't find anything, but still there were 50 children sick, because finished product testing does not make it all. You need to invest more in your global environment. This is something that was investigated in 2010 by ILC Europe publication by John Bassett, who used to be in Unilever back now, and now he changed his mind, he's in Danone. It's a better company. A bit challenge between all of them. And that's what is important. When you speak of contamination and you speak with a chemist, I'm a microbiologist, I'm not a very big fan of chemists. If there is any chemist in the audience, sorry for this. They believe that we are in the first situation. We have a contamination, it's regular. That might work with food cultures, in fermented food, and that's all. The two scenarios that are the most common ones is either a random communication or cluster one. And from the data we received from Abraken from 1986, which was based on Friesland Campina data, we know that in terms of pathogens, most of the time this is cluster-based. We had the same works in the early 2000s done by the French Food Safety Authority and the veterinary school on Listeria contamination in Camembert. And when you have a Listeria contamination in your raw milk cheese, 99% of your cheese is safe, and on one spot, you got them all. Which means that in terms of testing, you have two options. If you want to find the contamination, you can take a big proportion. It's more efficient to take multiple times small quantities, which means that basically in terms of testing, 1,000 times 1 gram will be more efficient than once 1 kilo. Not to mention about the limit detection of the method and whatsoever. But the way you sample is pretty important. What's also important is in terms of wording. I'm a big fan of this 2019 revision, where absence presence was replaced by detected non-detected. First, to comply with an ISO wording. In the ISO wording, in the methods, it's mentioned detected non-detected, because per se, the method is not perfect and might not detect the contamination. But you must also have in mind that even with a perfect method, you might not detect because there is nothing to detect in your sample. And the wording is very important. Detected, not detected means I didn't find it. Does not mean it's not there. When it was absence present, it was misleading for non-microbiologists to believe I test, it's absent, hey, I'm safe. But it's not by stating 5 times 25 grams of cheese that you know that the 10 tons behind you are fully safe. So this change of wording is really important. That's the only statistical slide, my promise. That's because for those who are interested, there is a very 80-page document from the Codex. If you have issues sleeping at night, I highly recommend this one. Slide. But once you get through it, it's very relevant because when you test, there is a consumer risk and there is a producer risk that you might test and find something which is acceptable, but still you find the pathogen, so you have to refuse it. Or you might test, it's not acceptable, but you didn't find it, so then that the risk is for the consumer. So when you test, it's always a balance between the producer and the consumer to accept or not a certain level of default. I'm not going to go further, saying let's investigate a little bit more about the analytical laboratory. That's your boat. And these are very nice pictures taken from Poitou-Charentes in the Marais Poitevin where I live. And I'm not funded by the touristic services of the Vienne, but if you have any questions, I just live near the Futuroscope. Very nice place. In the analytical laboratory, what's important is to have both capability and capacity. And the legal framework about the lab in Europe is not that clear. You have the legal framework, at least for the official labs or the official controls. But for the factory lab, it's not that easy. Sorry for the French. But this article, the Article 52 of the EGalim law, is something that popped out after the Salmonella agonite crisis of 27, and there are 2 points that I'm going to translate for you. If you are realizing auto-control in the food sector, you have two options. Either you must be accredited, or you must make ring proficiency. But if you work with a lab who is not either accredited or does not make proficiency testing, the result will not be accepted by the authorities. This is what's happening right now in France, and you can expect, because one member state cannot have stricter rules than the other, that it might, at some point, rise up at European level. How long will it take? No idea. 5, 10 years, I don't know, but it will come to a point that we can expect reasonably in the regulation, EU regulation, to find that food control laboratories will either have to be accredited or to make proficiency trial. When you make proficiency trial, that's a discussion I had some time with factories I've been working with. It's not the ISO 17025, which is for accreditation. It's the ISO 17403. Because sometimes you've got big companies and they have internal ring proficiency scheme for the internal labs, and they mention, yeah, it's safe for us because the reference lab of our company is accredited, but they're not using the right standard. So if you want to be fully compliant with the regulation, you are a food company and you make internal proficiency scheme. It's not the 17205 that you have to apply, but the 17403. And we had a publication, you have the link here, and I'm going to discuss too much, that we did with my colleague Annette Winkler from Cargill, formerly Mondelez, about analytical lab for the food industry, so it be in-house or third party. So that's always the huge debate. Should I have everything in-house, or have everything third party? As always, in microbiology, the answer is very clear. It depends. It's not that straightforward. It's not easy to say, do everything internal, do everything external. No, it's not that easy. One thing for sure, you must understand what's going on. So if you are externalizing the analysis, that's fine, but be able to challenge the laboratory you're working with. Because if you externalize and you have no idea what they are doing, guess what? They don't have any ideas either, and this might be an issue. Worst case scenario, this is what we have seen recently in Italy. You might receive COA from the laboratories which didn't do anything at all. It's pure fake document. That's the last scandal from Italy. But I cannot speak about scandals in Italy. I'm bound with a confidential law, by the way. No, it's just that it's very new. But you have this issue when they have the list outbreaks going on in Italy. They made an investigation and they discovered that from some food industry, the COA they were receiving were just the paper, but the analysis was not done. You might have this surprise sometime when you work with supplier and you ask for your raw material for the COA. Where does it come from? First, was it really done? Is it really a COA? Because if you receive a paper where it's mentioned certificate of quality analysis, they're trying to, is it a COC, is it a COA? You don't know. And how was the lab done? In supplier quality expectation, for example, from Mondelez or from Kellogg's, when you're a supplier of these companies, your factory can be accepted as a supplier and not your lab. They're accepting either one or the other. So that's something to have in mind. The lab plays a role. What's important as well is the method of analysis. It's the rope. So this is a Lac de Saint-Cyr, just near my place. Very interesting. For the method of analysis, it's always a choice. So I use a reference one, which most of the time is culture-based, or as a French, I should say, a Pasteurian method. Any German in the audience? We can launch the competition between Robert Koch and Pasteur. But most of the time we say Pasteur-based. Could be Koch-based, but it's Pasteur-based. Good news, we have a very interesting validation and verification scheme, which is done in the ISO 16140. I'm not going to run again the debate between the part 2 and the part 3. That's something you can find here, but have in mind that part 2 is part of the analytical supplier, so that's for the bioMérieux people here. And the part 3, that's your job. And that's pretty important to have in mind because this part 3 standard, in fact, is originating from initiative from Nestlé, because that's something they have in all their networks of laboratories. They have the accreditation from the EDQC, but for the food laboratories in each respective factories, they were asking for a verification that it was done. They were asking the same to the supplier. Was then a supplier of Nestlé, and I asked them, maybe if you can upgrade this to ISO standard, it will be very helpful, because as a supplier, we are asked by different companies to check that we are doing things good, and everyone has a different scheme, so a standard will help. This standard took more than 6 years to be published, because there was a huge pushback from a lot of the food factories not to go into this one. But guess what? It's pretty important to prove that you can verify that you're using a validated method. The point is very clear. Once you have a car, it's homologated. You need a driving license for the car. That's the same at the lab. If you receive a method from bioMérieux, they did their job, it's validated. They've got a part 2, that's fine. Do you know how to use it? Can you prove to your customer, either internal or external, that you know how to use the methods? That's what the part 3 is done. And this is something that is embedded in the EU regulation. That for the moment, in the last version, the part 3 is not written, but that will be that's something to be expected in the next update of the 2076/2005. You need to have validation against a specific reference method by an independent certification body. Then the discussion: should I accept Microval, AFNOR, or AOSC validation? As a French, I would like to say AFNOR is by far the best, but no, AFNOR and Microval are equally valid. What's important is not only the certification body, it's the reference method. If you got an AOSC validation, most of the time this won't be against the ISO standard, that will be against the US FDA BAP chapter. So it's not valid. Even if AOSC is using the 160/140 part 2 validation with the same mathematics, if they don't use the good reference method, it's not acceptable. So when you look at the 160/140 part 2 dossier of your supplier, make sure that they apply to the method which is in place in your regulation. In Europe, it's ISO. In China, it's GB standard. In US, it's US FDA BAM. Which means also for the supplier, there is some work behind. Depending on the market, your validation dossier might be valid or not. The analyst. So, I didn't have any specific people of someone fishing. So it's about his competences, and that's something important. We have this in the guidelines I mentioned before from the Codex, the 50 from Guidelines 50 from 2004, the factory sample. The factory sample is not the laboratory sample. That's something important. If you go into the ISO 7218 general examination for microbial examination, they mention, yes, everything you need to do for your sample at the lab. Who took the sample in the factory? How did he took it? Did he took it safely? How the sample is arriving? I was working in a factory, a milk powder factory, and you see all the samples arriving in the box from the factory. They were all covered by milk powder. So I'm not so sure if you have an issue, you can do something with it because they were all cross-contaminated. The lab didn't do anything wrong. Something messed up in the factory, and that's the issue, is that we are implementing a lot of effort in the lab, in the methods, but if at the start it's not taken appropriately, you're going to take wrong conclusions anyway. So that's what's important into this transmission to the laboratory sample. What about sampling on site? Who did this? Is it trained? What about the capacity of the sampling officer? It's mentioned in this guideline that you should have a sampling officer, someone who is trained to do the sample. How do you validate this? Are you sure you know who are your sampling officer in its respective factory? So far, I might be wrong, but from all the ISO standard I know, there's only the 18593, which is surface swabbing, that mentioned the capacity of the people who make the sample. For the other methods, regardless if it's for Listeria, Salmonella, sample preparation, and so on, we're taking for granted that the work was done in the factory. But there is no standard. There is nothing going on about the microbial contamination. So that's something to have in mind. When people make the sampling, they should not contaminate the sample, as well not contaminate the food chain. Because sometimes you have these issues as well, that people, when they take the sample, you ask them to take from the big bags, and they really plunge the arm in to get a good sample, but they plunge their arms in the big bags, and you lost 1 ton of product. So you have to be careful with this. Sampling is very, very expensive for a factory. Because when you ask to sample 30 times on big bags, if you have to discard 30 big bags, you have to discard 30 tons of products. This is not affordable. So you need to find another solution. So you can use automatic sampler, but how is it calibrated? Is it at the right place? Any potential contamination after? So the sampling on site at the factory level, it's not that easy. So the point is, what's the objective of the sampling? So as a reminder, it's not only finished product, it's also during the process. But if I want to test along the process and I need to open a closed line, it's maybe not the best idea ever. For cheese process, for example, that's pretty easy because you see the product along the process, so you just take a bite. For yogurt, for UHT milk, for milk powder, everything is closed. So opening the line is not always the best idea. Which means that sometimes you must have sampling sites in place, not something done in-house with the maintenance people, please, but something done with provider following EH or 3A guidelines so that you can sample at different point of the process. In UHT milk, for example, it's very important because if you have a contamination and you need to know what happens, and everything is closed, and you have more than 1,000 gaskets somewhere in the factory, and which one of them is a failure and you don't know, the option is to close the factory and clean everything. It's not economically sustainable. So you need to have the capacity to cut the process and be able to sample without contaminating the sample and contaminating the process. Which means that it's important to have sampling procedures in place, and sampling procedures is not at the laboratory level, it is at the factory level. And you need to have a clear, straightforward vocabulary with people who are not per se trained in microbiology. So that's pretty important. You need to use working with sampling officers. So it's not everyone can do the job. No, someone needs to be trained to have the capacity to do it in a proper manner. And he needs to have the right material for this. The best example we have is that sometimes when you receive a cistern, a milk cistern, and you have sometimes pictures you can still see online with people going on top of the truck, opening the truck, and with something, a dipper or whatsoever, taking a part of the truck in order to quantify the milk, which is present even for physical parameter. That's not the best way. So every time you receive a truck at the factory, you need to test and standardize what's inside. How do you make sure that you're not going to contaminate the whole truck when you take the sample? And that's valid for any type of other bulk deliveries. Finally, after all this testing, you caught a fish. I don't know if you recognize these people. Exactly. That's Fred Simon. I was supposed to meet in Paris for the French meeting, and he said, "No, I'm not there. I've got the COVID. But by the way, I caught a fish." So, but you caught a fish. Don't panic. It was meant to be. If you try to find something, guess what? You might find something. So this is where you apply the HACCP. Have a cup of coffee and panic. And this is already what I was saying, written in the Codex guidelines. If you manage to survive down to 4.11, actions to be taken when the microbial criterion is not met. If you test, you have two results: the one you want, the one you don't want. For the one you don't want, it's better to anticipate what you're going to do. I often receive the question, people call me, say, François, we found this in our product. What should we do? And I will say, why did you test? And when you receive a blank, you know it's going to take a while. If you don't know why you test, you don't know what you're going to do. And once you find something, it's not there that you decide, well, what am I going to do now with this result? You got a factory pushing behind. Should I deliver the truck? Should I deliver the tank? What should I do? So you're not saying, okay, we'll have a meeting next week and we'll discuss. No. Something's going wrong. You need to know right away. Which means that whatever you do, be prepared that it might not be as the one you want. And that's something we had in recent outbreaks. The one is from the Jif Salmonella trouble that was in the US recently, so peanut butter again. And again, people knowing that something was wrong in the environment, and again, people don't doing anything about it. That's something, right now, the trendy topic is to mention processing environment monitoring. I need to process in my environment. Fine, but what should you do? If you find something, you need to act. But if you always find something and you don't do anything about it, then you live with the danger. Oh, I found salmonella again. Oh, I found salmonella again. No, you need to do something with it, and you need to react. What does it mean or not? And that's what happened again for this one. As a reminder, we are just getting out of jail from getting the trial from the peanut butter outbreaks from 2009, PCA, Peanut Corporate of America. For those who remind these major outbreaks, which lead to the modernization of the FISMA in the US and all this mess we have for the next 2 years, in fact, that retesting is not an option. That's something you find a lot. You test, you find a pathogen, you retest, you don't find a pathogen. I must have been wrong the first time. No, definitely not. If you find something, Lavoisier, rien ne se perd, rien ne se crée, tout se transforme. If you find something, it has to come from somewhere. So yes, laboratory mistakes arrive. Yes, cross-contamination has arrived. But if you find something, don't out of the blue, don't go for retesting. Try to understand what's going on. And this is mentioned in the GEMRA document. You have a batch, you have a positive, you don't cut the batch in small pieces to retest and know what to deliver. No, once you have a batch and it's not compliant, the whole batch is discarded. Point. Whatever you do outside of this, you end up in jail. That's what happened with Steel Panel, and we have the same here with this Kerry Copac for Kellogg's, when people, the quality manager mentioned that deliberately he was not looking where the issues were in order to be compliant. So he knows something was going on. And that's what we have now in France, not Article 52, but Article 50. Once you have an auto control which is not in place and your non-conformity, even if everything is apparently under control, you have to inform the authority about the positive and about the actions you are doing. And then the authority will decide whether they leave you under surveillance, because if they're not happy and they want reinforcement plan, or if they put you out of business. With what happened recently in the Belgium Ardennes and in the north of France, not to mention the companies, but I think everyone got them, it's going to scale up at the European level. Right now, consumer associations and authorities are not satisfied by the way the management decisions are taken by major companies who find positives and don't make the right assessment and take wrong decision behind and still deliver products. We are speaking now of 2 criminal investigations going on. So the strike is going to be hard. And if you want to know how much it costs to work properly, we can take this recent Baricaibo example that we have in June and July. Manufacturer of lecithin, contamination of the global factory, shut down, getting back everything. That was 78 million euro, close case. For the Ferrero and the Nestlé figures, we're still waiting for the counting, but that's going to be far, far more. The Arlon factory has reopened under surveillance from AFSCA. The Caudry factory is not about to reopen soon. So time to conclude. This is good news. It's always breaking the mood when you speak about positives, but we have to deal with it. If you do not catch anything, do not conclude too fast that the lake is empty. Maybe you didn't go in the right place. If you want to make sure that the lake is empty, you have to come several times at several locations, several times of the day. And if after 100th time, indeed, you don't catch any fish, the lake might be empty, but it's not one that will take you all. So you must also do trend analysis. Also important, always start with the why, to introduce a little bit my next co-speakers. Congratulations, you are indeed at the lake. You were looking for St. John dory. So for those who don't get the joke, St. John's dory, it's the sea fish. You're in the lake. Chance of finding are pretty poor. So right now, and that was what you have in the microbiological components, the purpose of the testing and the rationale behind the microorganisms. I know Listeria is ready to eat foods, but if you're dealing with canned foods, I'm not so sure it's worth investing a lot. Maybe there are other bugs which would be far more interesting that you don't have per se in the regulation, but you should have a look. So another, this one is interesting still. Another document from the Codex, from the GEMRA, is the microbial risk assessment guidance for food. And voila, that's it for me. Thank you for your attendance.